Welcome to The Explainer. I'm so glad you're joining us today because, wow, we are about to take a magnifying glass to one of the most misunderstood and, frankly, most fascinating industries on the planet. Now, if you read the headlines, you've probably seen the crazy numbers. Global data center spending is projected to exceed $650 billion by 2026. Tech giants are pouring over $700 billion a year into building these massive facilities. It sounds like a modern-day gold rush, right? A totally guaranteed financial bet? But as we'll see today, the reality is far more dangerous and, honestly, a whole lot more fascinating.
Okay, let's dive into this by completely rethinking a basic assumption. When you picture a massive data center, what do you think they're actually selling? For most of us, the obvious answer is server space or cloud computing or maybe digital storage. But actually, scratch that. That is entirely wrong. Those are just the products that sit on top of the real product. The data center itself, it's not a technology business at all.
Here is the punchline. A data center is, at its absolute core, just a highly regulated, phenomenally expensive extension cord. Yep, what they actually sell is conditioned, uninterrupted electricity delivered to a specific location with absolute fail-proof reliability. You're basically buying power from a utility, wrapping it in extremely thick concrete walls, backing it up with massive diesel generators, and selling that exact same electricity back at a massive markup. It's beautifully absurd when you really think about it. Everything else, the servers, the networking software, that belongs to the tenant. You just keep the lights on. But as it turns out, keeping those lights on is one of the most capital-intensive endeavors in modern real estate. Part 1. The true cost of AI, shattering old models. Artificial intelligence has arrived, and it is completely rewriting the financial playbook for these facilities. You see, for decades, the industry's standard was built around traditional workloads. We're talking things like web hosting or streaming. Those server racks draw about 5 to 10 kilowatts of power each, and you can easily cool them with regular air. But an AI training cluster? The newest systems pull 120 to 135 kilowatts from a single rack. To put that into perspective, that is the electricity consumption of 40 American homes, concentrated into a single cabinet the size of your kitchen refrigerator. Air cooling becomes physically impossible at that density. You literally cannot blow enough cold air to keep it from melting down. You have to build direct-to-chip liquid cooling from the ground up. You can't just retrofit an old building for this. The plumbing, the floor loading, the power distribution, it's functionally an entirely different and much more expensive building. And because it's a completely different type of building, the costs have just skyrocketed. If you want to construct a fully fitted out 100-megawatt AI-optimized campus today, it will run developers a staggering $2.5 billion. That is not a typo. $2.5 billion. And mind you, that massive check, that's just for the building itself, before you've even factored in the astronomical cost of the land underneath it, which, let's be honest, you're really just buying for the right to plug into the local power grid. Now, what's really interesting is exactly where that budget goes, because a data center is essentially an extension cord. Power infrastructure alone devours 40 to 50% of the entire construction budget before a single server is even plugged in. Just for a 50-megawatt facility, you need a multi-million-dollar substation, you need transformers that cost up to $2 million each, you need $60 million just for backup diesel generators that you pray you'll never actually have to turn on, plus up to $25 million in battery systems just to bridge the gap if the power ever cuts out. You are hundreds of millions in the hole before day one.
Moving to part 2, the supply chain nightmare, equipment delays. Because when you're building a data center, all the money in the world can't always buy you time.
Let's look at the development lifecycle. According to McKinsey, the time from a mere concept to actual live power is now 3 to 6 years. You've got up to a year of just site selection, another year and a half of permitting, a year and a half building the shell, and up to 3 agonizing years just fitting it out. As a developer, this timeline represents a terrifying gap. It's a prolonged period of time where you are bleeding millions of dollars in cash, desperately hoping the market conditions don't change before you can finally open your doors and start collecting rent. And the biggest culprit for that timeline is this incredible number, 160 weeks. Over 3 years. That is the current lead time for high-voltage transformers, the single most critical piece of equipment in the entire building. Because major manufacturers are fully booked through 2030, which is honestly just staggering to comprehend, developers are forced into what's called front-end procurement. They are literally gambling millions, ordering these multi-million-dollar transformers years before they even have a building permit or have even acquired the land.
They're just praying they can build the facility fast enough so the equipment doesn't just sit in a warehouse depreciating.
Part 3. Where the real money lives, beyond renting space. So, say you survive the construction gap and the building is up. Let's explore what happens to the money once this multi-billion-dollar facility is finally powered on. Once you're operational, electricity is the massive beast eating your operating budget. For AI facilities, it can consume up to 70% of your ongoing costs. If you put a 50-megawatt facility in a place like Singapore, where power is expensive, you are staring at a $130 million annual electricity bill. $130 million a year, just to keep the lights on and the servers cool. It buys you absolutely nothing but the right to remain operational for another 12 months. Because electricity is so punishingly expensive, the entire industry obsesses over a metric called power usage effectiveness, or PUE. Simply put, it measures your facility's total energy use against just the IT equipment's usage. A PUE of 2.0 means you waste as much energy on cooling and lighting as you actually use on computing. So why does this matter so much? Because for a 100-megawatt facility, improving your PUE by just a single decimal point, say from 1.5 down to 1.4, can save you up to $31.5 million a year. It is absolutely one of the most consequential numbers in the entire business. And this brilliantly illustrates a wild truth about the industry. The real, hidden profit? It isn't in leasing space. It actually lives in a simple fiber cable. It's an interconnection. When two tenants in your building want to exchange data directly, they pay a monthly toll for a physical fiber optic cable connecting them, called a cross-connect. That cable costs a few $100 to install, but it generates a recurring monthly fee forever. Industry giants like Equinix generate over $1.5 billion annually just from these connections, operating at over 85% profit margins. They didn't just build buildings, they built highly profitable toll booths.
This brings us to part 4, the billion-dollar gamble, structural risk. The margins are absolutely there if you get it right, but this highly leveraged house of cards can easily collapse.
The physical infrastructure is nearly indestructible. The financial structure can collapse in months. This quote perfectly summarizes the cautionary tale of 6A Technologies. They were one of the largest data center providers in the world with over 60 facilities, a totally legitimate business with real tenants, but they carried about $2 billion in floating rate debt. When the Federal Reserve aggressively raised interest rates in 2022 and 2023, their interest expense nearly doubled. The data centers were fine, the physical infrastructure was perfectly intact, and the tenants were paying. But the macroeconomic environment shifted, creating a billion-dollar maturity wall they simply couldn't refinance. They filed for bankruptcy, sold for pennies on the dollar, and equity holders were completely wiped out in less than a year.
To show you just how razor-thin the line is between massive financial success and quietly bleeding to death, consider a projection for a hypothetical 20-megawatt facility in Dallas. In our optimistic scenario, things go smoothly. High occupancy, great rates, and you're clearing $4.3 million in positive cash flow. You're thriving. But in the realistic scenario, you hit a few bumps. Occupancy is slightly lower, your expenses stay fixed, and suddenly you are bleeding $6.5 million a year in negative cash flow. You aren't bankrupt yet, but the walls are definitely closing in and your lenders are getting very, very nervous. So the crucial point here is understanding exactly what causes that massive $10.8 million swing between thriving and bleeding to death. It wasn't a massive fire, it wasn't a catastrophic internet outage, it was entirely mundane. Your transformer arrived 7 months late, a few competitors opened their doors at the exact same time, driving down prices, and the local electricity rate went up by just 2 pennies. That is literally all it takes to ruin the investment and push a massive facility toward restructuring. Which really leaves us with this final, provocative thought: is betting on the future of electricity actually worth the risk? Because, as we've explored today, building a data center is not just erecting a warehouse for blinking lights. It is a massive, highly leveraged financial bet. And the hardest part isn't finding the tenants. The hardest part is simply surviving that years-long financial gap between writing your first multi-million-dollar check and finally collecting your first rent payment. The demand for data centers is undeniably there, but the house edge on this gamble is far tighter than most people think. Thank you so much for joining me on this explainer, and I'll catch you on the next one.